breakout session. We're going to move right on to Jake Cox. Jake, are you on the phone?
Yes, I am.
All right. Your slides are up, and I believe we're ready for you to go.
Okay, thank you very much. Good morning, everyone. This presentation is about a comparison of Flexilent and Clockwork as static tool analysis that we used on the C++ code for the MPCV project. The objective of this presentation is to determine the value of using Flexilent in addition to Clockwork. And what I mean by that is the tool used most was Clockwork. And the objective of the work involved in this presentation was to see if it was worth using Flexilent as well. Okay, and it's not a general comparison of taking the theoretical manuals of what these things could potentially find. It was comparing results on a particular build that we were working on at the time. Okay, and also all ITAR data has been scrubbed from this, so you'll see lots of things where it says file path, and that would be in the original analysis a real file name. The flight software consists of 1,200 files with 831,000 lines of C++ and C source code. And these numbers came from the Clockwork tool. The tools used were Clockwork Review Release 9.5.3 and Flexilent version 9.00H. And to make sure that I got the comparisons right, I made two files of the files that the two tools had looked at and ran a difference across them. And it showed me that my Perl script that was used to run Flexilent does not recognize capital extensions. So SWAT was kind enough to help me out with the Perl script so we get rid of this problem. And that left out one file out of the analysis. So I wasn't willing to go through and rerun it just for the one file. When I compared the file sets in the warning list from Clockwork and Flexilent, I found that there were 516 files in the Flexilent results that were not in the Clockwork results, and 79 files in the Clockwork results that were not in the Flexilent results, which I found surprising because they produce enough error or warnings that I was surprised that there was any file at all that either tool would not report something on. And my belief is this would be a good thing to look at for a future presentation or just future work. Okay, part of our process, particularly with the Flexilent tool, is to filter warnings out that we think we will never find any issues with. And since this was C++ and the original filter list was for C, additional items were added to the filter, which you see here, and the NASA PM for the project signed off on this before the analysis was done. Okay, once we get the warnings out, Clockwork reported 4,088 warnings, and 13,567 warnings were reported by Flexilent. When I lined up the Flexilent warnings with the Clockwork warnings, I found that there were 137 duplicates in Flexilent and 121 duplicates of, 121 duplicates of Clockwork by Flexilent. And in that set of duplicates, 13 issues were written. Now, there were 71 warning types that Flexilent had that did not map to anything in Clockwork, and 17 Clockwork warnings that didn't map to anything in Flexilent. And once again, this was taking real results, not things from their manual to line them up. And here's a list of all the clockwork warnings that came out of the analysis. And the ones with the blue lines are for C++. And you get a caveat here because we had been using clockwork repeatedly. The counts may have varied over time, and this is for the particular build that was done with FlexLink as well. And here are all the FlexLink warnings, which actually there's 2 more slides of all the FlexLink warnings. And you'll notice that there are a whole lot more warnings that FlexLink issues than clockwork issues. And a large part of this presentation is showing why that the results of that being true. If you'll notice 734 and 736 in the right-hand column, loss of precision int to int. FlexLink is much more fine-grained in the kinds of warnings that it puts out. And these are all from C. And the first slide for the C++ warnings is here. And then in the second slide, some more of the C++ warnings. If you look at the second row from the bottom, you get a C-style cast, which had 4,500 results for that. And the project actually has a coding standard that says not to use C-style cast. Looking at it, they were all coming out of the MATLAB tool, so from the autocoder, and there was a exception for autocode tools to be able to use that style of cast as opposed to manually coded files, which we're not supposed to. So that actually cut down the effort on doing the analysis by about a third. A little bit of detail on the ones I mentioned earlier about the loss of precision. The descriptions you see in bold come out of the FlexLink manual. And the word integer in the description isn't referring to the type in the assignment. It's referring to the number of bits in the types in the assignments. So if you look at the 734, it's talking about trying to squeeze a larger integer, like a long, into an int. And then 735 is a long double into a double. So you would have 128 bits to 64 bits. They just look kind of weird when you're looking at the manual, and they all appear to be the same thing. Here is a list of the warnings that Clockwork had that FlexLink did not. And the one in blue I wanted to talk about actually pointed out a case where there was unreachable code. And when we looked at it, the unreachable code was because there was a function that was supposed to calculate something that was completely commented out and returned true. And later we found out that they really needed that function to perform that calculation. And so that was one thing that Clockwork found that FlexLink did not. And this is the first of several slides for what FlexLink found that Clockwork did not. One was an out-of-bounds pointer, which we wrote an issue on. Another one, which was interesting, if you're familiar with the C programming language, a backslash continues a line onto the next line. And in this case, it continued a comment onto the next line, which basically swallows the next line into the comment. So, and once again, this is something that FlexLink found that Clockwork did not. Another thing was the shift left of sign quantities. If the sign bit is lit and the value is shifted, the sign bit will extend. And so if you're trying to do masking to find out what should be on and what should be off, it's possible that you end up with bits that are lit up that you really didn't want lit up or didn't And if you look at 1415, the blue line there, pointer to a non-pod class. And after looking this up, pod means plain old data. So they're passing a class or struct into a mem copy that has data that could be dynamic. So instead of performing a deep copy, which they might want to be doing, they're performing a shallow copy of the data type. And also on 1529, the correct way to define an assignment operator in C++ is to first check to see if you're copying A to A, copying the same thing back to itself. Because if you don't do that, and there's any memory allocation, you're going to start leaking memory and so forth. So it found 5 instances of this in the source code that Clockwork didn't find. And FlexLent also had a lot of warnings that dealt with constness. When things should have been const that weren't declared const or could have been, or violations of it. I had a long discussion with the flight software manager about they had declared a function that was as const for the class, but then returned a pointer to a data member inside it. And so, well, why did you do that? That's kind of silly. You know, not necessarily wrong, but the definition was bizarre. Okay, here is on the left-hand side you have warnings from Clockwork. On the right-hand side you have warnings from FlexLent. And this just shows the mapping of kind of what we found in Clockwork, but we also found in FlexLent. And as you can see with precision loss in the first case, did I do that?
I did it.
Oh, okay. So the precision loss on the left-hand side mapped to multiple FlexLent warnings. And that gets repeated quite a bit. And there are a few cases where, such as the bottom row that I can see here, with the NDP, which is a null pointer dereference, where Clockwork had a couple of different warnings that map to a single FlexLent warning. So some of the discrepancy in the counts is just the way the two tools go about reporting results. In this particular case, dealing with uninitialized class members, they report them the same way. So I ended up with 9 warnings for FlexLent and 9 warnings for Clockwork. However, the precision loss they treat somewhat differently. With Clockwork, it reports all of the same problem on the first line that it occurs. Whereas FlexLent has a different warning for each instance, at least within the file. And this is somewhat important because if you're dealing with the same thing being repeated, with Clockwork, you only perform the analysis once. With FlexLent, you've got to look at each one of them and hopefully remember it's an instance of what you already did. So the Clockwork method of reporting this can be quite a bit of time saving. The same is true for null pointer dereferences, where Clockwork will put a list of this occurs again and again and again in the same warning. Whereas with the FlexLent, you've got to look at it each in the individual time. The FlexLent, in this particular case, if you look at the line at the bottom of the slide where it says a float is equal to a float plus a double, the way this is accomplished in the processor is to coerce the float on the right-hand side into a double, perform the addition, and then remove the high-order bytes from the resulting double to push it into the float. Flexolent is reporting the coercion of the float on the right-hand side into a double and reporting the loss of precision as you move the double back into a float, whereas Clockwork only reports one error for the loss of precision. With the unused values, if you look here, one thing that they do differently is Clockwork is reporting the error when the assignment is made that isn't used, and Flexolent is reporting the same exact error where the second assignment is made and the previous value wasn't used. So your line numbers don't add up for the same error. And this is a chart of the issues that we got out of Flexolent. So we reported these issues to the project. There is a typo at the bottom of the slide where the last row got duplicated for description and subcategory, in case anybody noticed that. I will correct that for the and resubmit it. But we did find multiple issues by running Flexolent on the build and performing the analysis. We found issues that Clockwork did not find. And this is an interesting slide. For those issues that we did find, if you look at the first line, there was one warning resulted in one issue. If you look at the third line, there were 1,028 warnings that resulted in 10 issues. So the false positive rate on that was very high, whereas some of the warnings always resulted in an issue, such as the bottom row. And this slide is mainly to show, after running Clockworks 5, 6, 7 times on the flights, on versions of the flight software, since they're not really developing anymore, they're mostly bug fixes, the well is kind of dry as far as finding new and permanent issues with that tool. It's already found everything that is really relevant and meaningful. Okay, the recommendations that I have after doing this is that Clockwork is easier to use. So given time and resource restrictions, that is the tool of choice. But since each doesn't find things the other does, as time and resources permit, using Flexolent to supplement Clockwork is a valuable thing to do. It would be nice to be able to come up with a script that found the intersection of the warning set between the two tools, so you don't have to end up performing the same analysis twice on the same potential issue. Due to the nature of the way that they do report issues differently, this is a fairly tough nut to crack. And I believe I'm ready for questions.
Okay, are there any questions in the room?
Hi, Jean. This is Steve Driscoll. One of the things that the guidance standard control does, it takes 32-bit words and then truncates them into 8-bit words for recording. But I don't think that kind of truncation would be detected in the tool as an error necessarily. One of the things I'm worried about is whether or not everything's in the 8 bits that it gets truncated to. Any thoughts on that?
Well, both tools, if you make an assignment of a 32-bit value, 32-bit integer value, to an 8-bit integer value, those tools will put warnings out on that. Is that what you're referring to?
I was asking if you get the warnings on that. Yes.
Yes, you get lots of warnings. And the biggest problem is that happens a lot. And, you know, if it's the number of thrusters or a thruster ID, you know, it's probably not a problem. I know that with the MPCV, they were much more interested in those kinds of problems than a lot of the science missions in trying to keep all their data types straight.
Okay, that's helpful. Thank you.
Any other questions? Any other questions in the room? Okay, do we have any questions on the phone?
Not at this time.
Is anybody really out there?
We're here.
Okay.
Okay, I have a question on the web. Hang on just a second. Okay. Could the configuration of Flexlent and Clockwork also have something to do with the difference in the tool's results, i.e. missing or including files?
It certainly could be. Working with SWAT to get the configurations to be as identical as possible is probably a very good idea. The configurations on both tools are fairly standard in the sense that we've been using the same configurations for years, essentially.
Okay, I have another question online. Says Clockwork used to have some bug that shows false alarms for IDEX. Interested more than 2 deep. Is it still there?
I have no idea. Well, it was a bug reporting what kind of warnings?
IFDEFS.
If deaths, okay, in the preprocessor directives. There aren't a whole lot of warnings with either tool with respect to the preprocessor. Interesting question, I don't know.
Another question online, was there a check of the checkers in Clockwork compared with Flexlent?
I'm not sure I understand the question.
Was there a check of the checkers in Clockwork compared with Flexlent? Okay, I don't know how to expand on that.
Okay. In Flexlent, you can turn on and off certain checks, and you can also do that in Clockwork. Is that what the reference is to? As far as the internal working of either tool, you know, I know what comes out of it.
Hey, Jay.
Oh, what it's doing inside of itself, I don't know.
Hey, Jay, this is Rick S. Yeah, it sounds like that he's just asking about the list of the things that Clockwork checks against the list of the things that Flexlent claims they check. So
Right.
then we take a starting list and say, this is what Clockwork claims to check, and this is what Flexlent claims to check. Try to compare the two.
Okay, and it would be an interesting work effort to go through the two lists. In the presentation I gave yesterday, one of the things I said I wanted to work on was to get lists of warning types from both tools with respect to the software standard checklist items. And that would do some of that, as opposed to lining the two tools up and then trying to draw lines between each one's warnings.
Hey, Jake, this is Carolyn. The static code analysis working group is working on this, but we're not there yet. We're in the process of creating out the capabilities and the limitations for each of the current versions of the revisions of the code. So I think there's an effort that is starting to bubble up in this area.
This is Lori. We do have a question from the phone lines when we're ready.
Okay, go ahead.
Okay, Mary, your line is open.
Mary,
Your line is open. Can you hear me this time? Yes, we can. Your line is now open. All right. I've been trying all morning. I haven't been able to get through. It's wonderful. It's open. Just a quick question. He had mentioned with the flexible in the reporting, it's giving you a different warning for each instance, where in the clockwork you only see it once. So that to me, it's lumping those instances together. And I guess if you're going through quickly, of course, the clockwork is surely going to be better. But is there a potential that maybe you're missing something in that lumping? Because as reported before, flexible views were picked up that clockwork didn't find. Do you understand kind of where I'm going with that?
I think I do. When looking at that, when performing the analysis of it, I will look at the other lines to see if they're the same thing. But I already have, but I don't have to go back and think of what exactly is it trying to say. I've already done that step.
Right. So the one is saving you time. I'm just not wondering if you're not missing something that the other one may have picked up.
Well, I certainly try not to miss anything. So, you know, is that a possibility? I hope not. You know, part of that's the process of going through the work is to try and not miss things like that and be aware of that potential.
Right. But I guess I'm more concerned is if it's listing it by instance, how do, I guess, let me rephrase this. You're seeing it once in clockwork because it's combining those different instances.
Right. And normally it would be like, you know, buff pointer is being used when it could be null. And this also happens online, this, that, and the other thing. So you're dealing with the same variable. Well, if it were a different variable, it would be a different warning.
Okay. I see where you're going with. Okay. Thank you.
You're welcome.
Okay, we are 40 seconds away from lunch, so I'm going to go ahead and cut off the questions there and send anybody else that has questions.
Jennifer?
Yes, Jake.
Okay. To whoever asked that first question about the count of static code analysis things, if he wants to meet in the break room, I have an answer.
Okay.
Okay. Thanks.
And I have sent the list of questions that came through on the internet to the breakout session, so hopefully they will join you there. And then also, as a reminder, we have the 12:15 breakout session that may continue some of this discussion. It's in the breakout room and in the breakout session online. So if you come back in here at 12:15, I'll just send you out there. But we have lunch now until 1 o'clock. See you back then. Lori, we'll just restart at 1 on the telecon.
Okay, and that's 1 o'clock Eastern, correct?
Yes.
Okay, great. Thank you so much.